Okay, Bacho, we have to see today how to solve the quadratic equations through factorization. You have to remember some points here. The first thing that you should remember that your equation should always be like in this form. All the terms on the left hand side and the right hand side should have only zero. Okay, so your right hand side should always be equal to zero whenever you're solving any equation algebraically. Okay, especially these quadratic equations. So if you look at these questions here in the 16th, 19th and onwards questions, so you will have to shift these terms to the left hand side first and then you will start solving them. Okay, the second thing that you should always remember that you cannot cancel out a variable. Like many of you, for example, if you look at this x squared equal to 6x, now what happens, students, they see, okay, this is x squared equal to 6x. So they think that we can cancel out this, we can cancel the x with the x squared. So we have, like if we divide both the sides by x, you see, so this x cancel by this. So you have x equal to 6. You know what is the loss or the disadvantage of doing such a step? The thing is, remember, the quadratic equation has two solutions. Quadratic equations has two solutions. Like if there is an equation like this, which is going to be x plus 2 equal to 0. This is a linear equation. This, when you solve this, you get only one value of x, okay? When you have a quadratic equation, like you have x squared equal to 6x, now for this linear equation, the power is 1 here. This power is a hint for you. If the power is 1, there is one solution. If the power is 2, there have to be two solutions. And similarly, if you have a cubic equation, you should get at most 3 solutions for a cubic equation, okay? So if you're going to divide both the sides by x, you're going to lose one of the answers, one of the values of x. Let me tell you how. Look at this. This is x squared equal to 6x. If you have moved this 6x to the left, applying the first rule that your equation should be all the terms on the left hand side, and then you should have that equal to 0. Then you see I can take a common over here. This is x into x minus 6, and that is equal to 0. Now, this means that either your x is equal to 0 or your x minus 6 is equal to 0. You know why? Because if for example, if you're multiplying a with the b, okay, and your result is equal to 0, this means either a is 0 or b is 0, or maybe both of them are 0. That is why the result is 0. Are you understanding what I'm saying? That when you're multiplying two numbers, for example, these are two characters, two variables, and the result is 0. So at least one of them has to be equal to 0. Okay? So that is why when you have x into x minus 6, or maybe in future when you will be doing that middle term breaking, so you will be having x plus 1 times x minus 2, that is equal to 0. So you have to say that, okay, either x plus 1 is equal to 0 or x minus 2 equal to 0. Obviously, if one of them is 0, only then this into this has to be equal to 0. Okay, got it? Now, this has been seen in the past papers that examiners really like confusing the students. I have seen such questions where the question was x squared um, or maybe x into x minus 6, and that was equal to 5, or maybe minus 5. Okay, that was equal to minus 5. Now, what students do over here, they are mistaken. They say, okay, either x is minus 5 or x minus 6 is equal to minus 5. Now, this is totally wrong. Why it is wrong? Hmm? बच्चों बताओ, why doing this is wrong? Why we can't write it like this? Hmm?
Sir, because there is x square.
Because all numbers have to be on the left hand side.
Ah, you have to shift all the numbers to the left hand side, okay? And your equation, you should start with this. First, you make it like this, okay? And this doesn't mean like if this is x into x minus 6 is equal to minus 5. So either one of them is going to be minus 5. So this is totally wrong. That can only be done in case of 0. When you have two expressions being multiplied and you have that equal to 0. So then any one of them can be equal to 0. So please remember, whenever you're solving an equation, you have to move all the terms to the left-hand side, and the right-hand side should only have 0 there and never cancel the variables, okay? Now let's start solving these equations. Now, let's say we have here, now this first question, that is going to be, you know how to solve this. I'll be starting with the fourth question. This is 3x squared minus x. So all the terms are there already on the left hand side, okay? So I can just take x common from here. This is 3x minus 1, that is equal to 0, okay? So either x is equal to 0 or 3x minus 1 is equal to 0. So we got two solutions. One is x equal to 0. The other is x equal to 1 by 3. Look at that 19th question. The 19th question. We have x squared equal to x, okay? So remember, all these steps, all the terms, they have to be on the left hand side. X squared minus x equal to 0. So you take x as common. This is x into x minus 1 equal to 0. Okay. And then you say, okay, either x is 0 or your x minus 1 is equal to 0. So these are the two values of x, 0 and 1. Look at this.
Sir, question 28 कैसे करेंगे?
Question number 28. Yeah. The 28th question, this is 2x squared equal to x over 3. You should do that cross multiplication before you take this x to the left hand side. So when I do that cross multiplication, so you have 6x squared equal to x. And now we move this x to the left hand side. This is going to be 6x squared minus x equal to 0. And now your x is common here. So 6x minus 1 equal to 0. So you have x equal to 0 or you have 6x minus 1 equal to 0. So your x is going to be 1 over 6. So these are the two values, 0 and 1 over 6. These are the two values of your x over here. Okay? Similarly, if you look at the questions in the upcoming exercises here, yeah, this he has taken you to the quadratic formula, so we'll stick to this, okay? And if you look at the questions here, like, these are all simple equations where you only have two terms over here, okay? So you see, these are the typical quadratic equations that can be solved through middle term breaking, okay? To solve these equations, you should be very good at middle term breaking, or even knowing that which of them can be written as a whole square. Look at this fourth question. So this is x squared plus x minus 6 equal to 0. So what are the two numbers whose product is minus 6 and whose sum is 1? Whose product is minus 6 and the sum is 1? You have 1 times
25
6.
by 1. सर यही का है
1 and 6.
No, sir.
If you multiply 1 by 6 or 2 by 3, you get a
3 minus 2.
Yeah, so this should be, since the product is minus 6, so one of them has to be minus. So this is the pair over here, 3 and minus 2. Their sum is 1 and the product is -6. So you will write it as x squared minus 2x plus 3x minus 6 equal to 0. So you have x common from these two. You have 3 common from these two. And then you have x minus 2 into x plus 3, that is equal to 0. And then you say that, okay, either your x minus 2 equal to 0 or your x plus 3 equal to 0, okay? So you have one of the solutions x equal to 2 and the other solution is x equal to -3. Let me see who will tell me about the 28th question, how to solve this 28th question. The 28th question. We have, in the 28th question, we have y squared minus 2y plus 1 equal to 0. Yes, let me see who will tell us how to solve this one. Yes. QB Samiha.
Sir, -2 plus 1. No, 2 minus 1.
So what
-1
is the product that you're looking for?
1.
1. So then why are you saying -2 and 1? It is only 1 and 1 because 1 into 1 gives you 1. But since the sum you are looking for, that is -2, so therefore this should be -1 into -1. Got it?
Yes, sir.
Acha, now you guys have also learned about the whole squares. This was basically a whole square. Look at this. This is y square. Okay, this is 1 square, and this is -2 into, what is the product of y and 1? That is y. This is -2 into y. Okay, so you could write it as y minus 1 whole square. That is equal to 0. So when you have a whole square, so you take the square root on both the sides, you take the square root of this, and you take a square root of this. This is cancelled by this. So this is y minus 1, and the square root of 0 is going to be 0. So y equal to 1. Whenever there is a whole square, you get just one solution of that quadratic equation. Even if you had factorized it, like look at this. For example, if you're using this combination, -1 and -1, look at this. What would you get? This would be y squared minus y plus 1 equal to 0. Okay, you have y common from here, y into y minus 1, and then you have a minus common from here. This is y minus 1. Okay, and then this is y minus 1 into y minus 1 equal to 0. So it means either y minus 1 equal to 0 or y minus, both are same. So you get y equal to 1. And Ali knows it. We call it the repeated roots, the equal roots. Ali, yaad hai when you have the discriminant is equal to 0, then you have two equal and real roots. So that is what happens there in your add maths.
Yes,
Okay?
sir.
Hassan, sorry.
Sir.
Yeah. Yeah. So that is how you have the, I mean, though it is a quadratic equation, but you're getting just one root. There are two roots, but they're both equal. Okay. So this is because it was a whole square. So which of these equations over here that is also a whole square? Let me see if you figure out which equations are representing the whole squares here. There are two I can see. The two of them I can see.
Number 19.
And 22, exactly. Because number 19 is x plus 1 whole square. Okay. And number 22 is x minus 7 whole square. Yes, perfectly all right. Anyhow, bacho, you must take its screenshot, okay? And you have to practice all these questions. And I might take a test from this exercise 3.31 tomorrow, because this is about the 3.31 and 3.32. So you take its screenshot of this, Okay.
This exercise is page number 89 on our books.
Okay, very good. And then the next exercise. So this is the ditto same exercise, Hassan?
Yes, sir.
Okay. And you have to
All
practice
questions are
this, yeah, this as well. Okay, guys. So see you tomorrow then. Okay.
Thank you, sir. Allah Hafiz.